All right. For those that don't know me, I'm Jonathan. I'm one of the co-founders of Talisman, and I'll actually start with a little bit of a caveat or an apology. I have done this talk before at Sub-Zero in March. I delivered this talk. So for those that saw that or saw that in person or watched it online, you might have seen some of this stuff before. But it was pretty well received, and not so many people viewed it on the internet, so I thought it's a message worth delivering again, especially since we're on the tech stage here at Decoded. So I hope everyone here knows about Talisman, because we've been around for a while, and we have quite a kind of a user-facing, outward-facing presence in the ecosystem. But for those that are new, or those that haven't heard about Talisman, we're a product-oriented team working within the application layer to help users kind of use the ecosystem and learn about the ecosystem in an intuitive way. And we do this via 3 products, primarily our extension wallet that you can see here on the right-hand side. And we also have a web portal that allows folks to access some of the more kind of frequent use cases in the ecosystem, like staking and XCM and portfolio management. And we also have a multi-sig suite called Signin, which is more aimed at enterprises that need to manage their assets using the multi-sig palette that exists on Substrate chains that needs some kind of better controls since they are an enterprise and they need their assets managing in a more robust way. But I'm here to talk about the application layer today. And to illustrate what this is, I have a really, really rudimentary diagram of like the tech stack that exists in the ecosystem. At the bottom, we've got like all of the low-level stuff, peer-to-peer networking arrangements. And then on top of that, we've got all the node software, the Polkadot protocol, whatever cores you're running. These might be called parachains or paras or cores or whatever they're going to be called in the future. There are also some solo chains that Talisman supports. And then you might have some middleware, indexes, block explorers, oracles, whatever it is. This is also an important part of the stack. But right before the user, you have a really important section of the stack called the application layer. And this is the way in which the users interact with everything else. And so last year at Decoded, I gave a talk about how Talisman fulfills our role in the application layer. I spoke about how we kind of let the principles of censorship resistance, decentralization, permissionlessness, verifiability. I spoke about how the wallet and our job and what we've been doing at Talisman, we help those kind of propagate up through the ecosystem so that the user can benefit them, and we don't just hit the application layer and use a bunch of centralized services, and then it kind of defeats the purpose of everything else that this ecosystem has built. And today, I want to talk about how you guys who are building dApps and products and other applications inside of the application layer, specifically inside of the web browser, how you guys can do a really amazing job of kind of bringing the properties that exist further down the stack into your products to build resilient products, to build performant products, and so that the user can benefit, because that's the point. And we'll be doing this in roughly 3 parts. Talisman has built some utilities and some little libraries that help you guys iterate and test towards finding product market fit inside of the application layer, building on Substrate. Another part of building applications in the browser is having wallet support. And you want to be able to go to market with wallet support really easily, and that's something that we'll cover today as well. And in the 3rd section, we will increase the amount of hand-waving, grandiose statements as I describe how you can build a particularly resilient application with Substrate and Talisman, and why this might be performant compared to other ecosystems' efforts in the application layer. I think we really stand out as an ecosystem when it comes to this property of resiliency and verifiability with the type of applications that you can build on top of Substrate in the application layer in the browser. But let's get started. The first utility that I want to highlight is something that we built a while ago, maybe earlier this year. It's called Signin with Substrate. And for those that are familiar with the Ethereum ecosystem, you might have an idea of what this is already. It's an equivalent to Signin with Ethereum. It's essentially a standard for authenticating Substrate or Substrate account signature against the backend. So the users would have an experience roughly like connecting their wallet to a website. The website will then say, hey, you've got to sign in with this wallet. You make the signature with your key pair that's inside of Talisman. And then from your backend, you can issue a JSON web token that permissions access to some protected API because the user has proved that they own a particular Substrate address. And this is useful in a really wide range of applications. It's a very generic tool, a very generic primitive. We use it inside of Signet to share call data for the multi-sig transactions. This is a bit of information that actually lives off-chain. So we need a way to store it in a backend, allow a user to prove they own a particular account so they can access the core data for that transaction. But you guys can use it for anything that's like involves storing or fetching like auxiliary or frivolous data. I assume all the important stuff is on chain, but if you want a user to authenticate that they own a particular Substrate address, you can use Signin with Substrate to make that verification and access your protected API. But the use case that I want to highlight particularly with this is something that we haven't really seen people use Signin with Ethereum for, and I haven't seen anyone use Signin with Substrate for this, but I think it's really important. And that's finding product market fit by mocking and testing your pre-runtime product with a backend. So what I mean here is that the effort to build an application on Substrate, if you are kind of putting some business or application logic into a runtime, is really, really high. You've got to hire a bunch of Rust developers, train them up on Substrate, get them to implement your business or protocol logic inside of the palette, build a runtime, and then after you've done that, you might think about building a front end and testing your product in the market. But you've gone through all of this effort, and then you might get to testing your product in the market, that last step before the user in the application layer, and then you realize maybe some business logic is not what the market wanted or users wanted, something that behaved in a different way. You could go back to your runtime engineers and re-implement your protocol. This is why we see V1s and V2s all of the time. Imagine just saying, forget runtime development initially. I'm going to go straight to the market and kind of test my product, battle test it with users immediately. And you might be able to use something like Signin with Substrate to create a mock runtime. Put all the business logic in a backend. It's going to be super hacky and super short term, but at least it gives you something to kind of mock transactions or mock signatures against. So when you're building your front end and when you're building a runtime, you have validation that folks have already been exposed to your product because they have been testing with it. And you can use Signin with Substrate with this. Anything where there might be like a runtime call and you haven't implemented it yet, just like mock it, put it in a backend, get the user to like sign the message instead, and you can adopt this principle of like move fast and break things without having to kind of go back and re-implement everything in your runtime, which is pretty useful, especially as Core Jam and Core Time, and we have more runtime teams implementing more of their logic inside of palettes. You can test this in the market in a really hacky way, but it's important because that's what iterative development is all about. Lots of other things. The only other thing I'll highlight is we had a hackathon bounty for Signin with Substrate this year, and the winner ended up being this guy that is building this like Next.js template for building Substrate applications with Next.js, and he built an auth adapter with Signin with Substrate. It's a cute little tool. I'm glad that I saw it built, and you guys can check out his whole template if you want to move fast and break things when you're developing an application layer with .stack.xyz. This is a builder, a solo guy, and we should support projects like this in the ecosystem. This is everything that's in the head of a Signin with Substrate. You can take a photo of this, or there's lots and lots of documentation, but there's all sorts of things here that you can use in production or in your hacky move fast and break things. I'm going to mock my product before I have a runtime type of thing. It's very similar to what you've experienced with Signin with Ethereum if you have experienced using that in that ecosystem before. And there's documentation. It's available on NPM and Yarn, all of the good stuff that you'd expect from a node library. We've got you sorted. And there's also some support channels in Element and Telegram if you want to contact the team and use the product or use the library. Another kind of primitive that's pretty abstract and pretty general that we have inside of Talisman that you might not have heard about is the ability to just use the accounts inside of the browser extension to encrypt or decrypt a payload. We initially put this in the wallet for this project called Sumi. They were going to do this like cross-chain messaging protocol, and they wanted the messages to be encrypted when it went into the storage provider. They never ended up shipping, but we have it in the wallet anyway. So this functionality is here for you to use. MetaMask doesn't have it. I'm not aware of many other extension wallets that have this ability to use the key pairs inside of the wallet to encrypt and decrypt strings. But Talisman has it, and it's a pretty general primitive that you guys can use if you want to do like a message board or something like that. This is something that's nice, and it's really, really simple. We just got this encrypt message message that goes to the extension, and you need to provide the recipient public key. And then the same for decoding. You are the recipient, and you just need to sign that. So really simple. Feel free to take a photo or contact me later for these slides. So these are two pretty abstract, general primitives that are available inside of Talisman, or in the case of Signin with Substrate, outside of Talisman for you to use inside of your application that you're building inside of the browser. But eventually, you're going to want to ship. And you're going to want to put this out to the market, and you're going to want wallet support so that those folks that use Talisman or another one of the ecosystem wallets can connect, and it's smooth, and you don't need to go through this kind of gray period where you're trying to get integrations. And you can do that in Talisman pretty easily. We have this GitHub library called Chain Data. It's very open. We have a lot of open source contributors to this, but it's a really easy way to make sure your tokens, your images, your assets, your chains are supported inside of the wallet by the time you go live. So you can put any RPCs that you're running that you want us to use to communicate to the network in there, whatever kind of key pair types that you're using in your chain, anything to do with particular assets that you want token support for inside of the wallet, extension deposits, block explorer links, anything that you want inside of a wallet as an integration, whack it in chain data, and you'll have it supported inside of your application for your chain from the get-go. So there's no coaching your users through having to go to Talisman and switch on the network. It's going to work by default if it's in chain data. You don't need to add the contract addresses if you're an EVM chain or a smart contract chain, because you put it in chain data, every single one of your users will have it if they're a Talisman user. There's no kind of onboarding them into your protocol by getting them to perform all of these tasks and program the wallet. It'll work out of the box. And if you did want your user to add like a custom RPC, it's supported inside of Talisman, but you can just default to whatever is in chain data. So yeah, really seamless support. You don't need to instruct your users to do anything, and they can use the application as if it has been around for months and months and months and years and years and years. It's a really useful primitive. OK, so this is where I walk around the stage a bit and the hand waving goes more. I want to talk about how you can create a resilient application inside of Substrate with small dot. And to illustrate this, this is like a visual representation of how the interactions between the network, the dApp, the libraries, and the wallet behave at the moment. And one interesting thing to note is that in Substrate, in the ecosystem at the moment, with the current, let's say, default API, which is the Polkadot JS API, the dApp is in control of propagating the transaction to the network. The wallet doesn't do this. It's a really offline signing experience. It's your guys' responsibility to define the connection to the network that the user is going to be relying on when they are using your application. And right now, the way most people are doing it is they're just saying, I want the user to connect to this node here. It's some RPC that you guys are running, or one of the infrastructure providers are running. That is the only RPC or the only node that the user is relying on to connect to your network and to interact, pull chain state, propagate their transaction. And my pitch to you today is to forget this and instead run a light client inside of the browser. This essentially makes your user their own peer on the peer-to-peer network. You sync to the boot nodes. You connect to 40 or 50 different other peers. And suddenly, you're no longer relying on the one infrastructure provider or the one RPC. You can kind of be your own participant in the network. And this is pretty great for a number of reasons, which we'll get to later. But it's a really simple change to make. There's this Substrate Connect SDK. This might be outdated because I pulled these code snippets ages ago, so you should follow this up. but it is really simple. So you might have something like this if you're providing your users with an RPC, and all you want to do is just import this provider and maybe some chain specs from Substrate Connect. And if you want the user to use a light client, you can point them towards that chain spec and use the Substrate Connect provider. And you might say, well, this is a bit kind of fruitless. Everything works fine with an RPC. I've never had any problems. People always being able to connect to the RPC, pull the chain state, propagate a transaction. But I would say to you that it works until it doesn't. We've seen Infura kind of misconfigure their infrastructure, and they accidentally blocked a bunch of IP addresses. These users could not propagate transactions to DeFi. So you just want to make your application resilient. The user needs to be able to access these networks all of the time. And it's free resilience. When I say it's free resilience, your application is just as performant if you're running a light client in the browser than if you're using an RPC. So it's not the case where you might be using a Web3 application and you're incurring all these costs, like it's a bit more expensive, it's a bit slower, there's like extra steps involved. You can really kind of tune up the decentralization and tune up the resilience of your application by switching from something that's RPC-based to something that's light client-based. And from the user's perspective, it is almost indistinguishable. Like, it is free resilience. Unless they're running a really, really crappy machine, it's going to be just as performant. So it's a really important change to make. So going back to this diagram, you might be saying, OK, that's great. I'm mitigating against RPC risk. The RPC is no longer something that I have to trust in order to interact with the network and get my transaction propagated. But now you're still kind of trusting the dApp. The dApp might be malicious. It might be crafting a transaction that totally drains your funds. Or the dApp just might be unclear in its user experience. The staking dashboard is a good example, so don't. I'm not saying this is bad, but you might be using a dApp that kind of just accidentally or intentionally misrepresents what transaction you're going to submit. And so it really doesn't matter. If you're using a light client or an RPC, you're still propagating a transaction to the network that you might not have intended to. And this is where some work that Talisman has done maybe comes into it. You can mitigate the trust assumption on the dApp by kind of understanding that the relationship between the dApp and the wallet is not just a signing relationship now. It's also the ability for you to verify whatever transaction you're about to sign in a way that's totally separated from the dApp. So what Talisman does is we take the call data, the information about the transaction that comes from the dApp, then we take the metadata from the chain, and we decode what your transaction is going to be. And then we'll show you all of the arguments, all of the function signature stuff, as well as the palette documentation that the runtime developer has written. And this is a way for you to verify that the contents of the transaction is what you intended them to be. So that's kind of the user's perspective. You should always look to kind of verify this information when you're transacting on a dApp. You might have made a mistake in using the dApp. dApp might be malicious, and this is your way to always verify what you're signing before you sign it. And my message to runtime developers is that when you're writing your palette documentation, this is not just for your colleagues that are also kind of writing your palettes with you. This is information that can be propagated up to the user, and the user is using this kind of documentation to verify the contents of their transaction. So make it coherent. This is a batched call to join a nomination pool and set the claim permission to be automatic. And batch is OK because it's kind of in the name. You're batching a transaction, and you can see the two calls that you're batching. But we've seen a lot, some like palette documentation that's really incoherent. It's clearly not meant for the user. And so you should keep in mind that this is something that you want your users to see as well, because Talisman will be showing it no matter how ugly it is. We'll be taking your metadata, we'll be taking the call data, and we'll be showing this so the user can verify the contents of their transaction. And so you might be saying, OK, this is great. I don't have RPC risk because I'm using a light client, and that's mitigated against. I don't necessarily have as much risk on the dApp, because I can verify the contents of whatever the dApp has proposed before I sign it. But now I have to trust the wallet. You have to trust us to do this job of verifying whatever the transaction is. And I don't want you to trust us. That's a terrible idea. This is Web3. Oh, sorry, before I get to that, if your transaction or if your pallet is particularly common, then we will show like an even better, even more digestible screen. We've got some of the common like use cases in the ecosystem, like staking and governance, and in this case XCM. That will kind of decode the content of the transaction, and instead of rendering the generic screen you saw before, where it's a little bit ugly because we need to show all the information in like a JSON object, we'll actually show something that's super digestible. It's like a bit of a custom UI we made so that you can verify your XCM transaction in this case in a really, really easy to understand way. And so as I was saying before, you have to trust that we're doing this job correctly, and you shouldn't do that because we could screw it up. This is Web3. You don't trust what I'm saying. You have to verify yourselves. And luckily, this is getting a little bit better because of something that was announced by Bjorn yesterday. So you saw him announce the generic Polkadot app. This is some ledger application that allows you to use any Substrate network from the same application that you install on your ledger. And what's interesting is how this is implemented. What's happened here is we've added a new signed extension to a lot of the Substrate runtimes that verifies the metadata that the transaction was signed with. So when Talisman is taking some metadata and decoding the contents of your transaction, if that version of the metadata is wrong, or if it's old, or if it's incorrect in any way, the transaction is going to get to the network and it's going to fail. So now we're at a position where this is actually a really resilient kind of situation to be in inside of the application layer for Substrate, because you don't necessarily have to trust the RPC because you're running light clients. That RPC risk is pretty well removed. You don't necessarily have to trust the dApp because you're verifying the content of the transaction in the wallet before you're signing it. And in some ways, you don't necessarily have to trust the wallet because if we screw up the verification of your transaction because the metadata is incorrect, then the transaction will fail anyway. So overall, you've got a pretty robust, a pretty resilient ecosystem inside of Substrate, and this is why we're here. The axis on which we should be competing against are the areas in which Web3 is strongest, and resilience is certainly one of those things. And I think if you compare Substrate and Polkadot to some of the other ecosystems and look at what's possible to build in the browser environment in the application layer, Substrate really stands out in this regard. So if you're looking to build a product that has resiliency and kind of trust to minimization as one of its kind of core principles, then Substrate is probably a really good place to do that. OK, so this is a bit of a summary of what you can expect when you're building inside of the application layer. You're building your dApps, you're building your products, and in some cases, you're building a runtime alongside that as well. I hope it's useful. To summarize, you should battle test your products and find product market fit, because that's the important thing in the application layer. It's not infrastructure where you're marketing to other engineers, you're marketing to users, and you need to find product market fit, and you can use Signin with Substrate to find that. You can have launch time support from Talisman or other wallets by making sure they integrate into chain data. You can build a resilient application, which is kind of necessary if you're in Web3. If you're not aiming to build something that's resilient or performant along this axis, then you should probably go and build it with a back end and call yourself a Web2 company. And finally, I actually in March I didn't have this in this section, but you have a generic ledger application. So if you are building a chain, you don't have to build a ledger application alongside that. You'll have something out of the box ready, thanks to the work that everyone has been doing recently. And to watch out for in the future, there's a few things that your application developers can look forward to or keep an eye on. Firstly is Pappy. This is the new TypeScript API that we can all use to interact with Substrate chains. I can see a couple of the team members in the audience, and this is really exciting because maybe the wallet can be in charge of propagating the transaction to the network instead of having that situation we had before. And it's a lot easier from a developer experience perspective as well. And it's a lot more performant. I think we can expect some improvements to the address formats. Substrate chains often have different address formats, and there's some discussions about that improving the experience in the application layer pretty soon. There's now excellent multi-sig support. This is something that there hasn't necessarily been in the past, but we're definitely getting our way as an ecosystem with some really good multi-sig tools. And we've got everything kind of coming downstream from Parity with the changes to how the Parachains protocol is working and how cores are going to be utilized. So I'm sure there's going to be lots of ramifications for that inside of the application layer, and I'm looking forward to maybe updating you guys on how we've been thinking about that at the next Sub-Zero or the next Decoded or whenever that's going to happen. And yeah, that's the application layer, how you can build pretty performant applications inside of Substrate with Talisman and with what everyone at Parity has been doing. So thanks for listening, and come find me if you have any questions.